Hi everyone, welcome back to my math channel online today again. Today is a beautiful day, summer day in British Columbia, Canada. I wish everybody happy and looking forward to the nice summer. In this video today, I am presenting to you about the lesson in the polynomial function in the course of Math 12 Pre-Calculus that I am creating and designed, and is the math courses online. So I think that it should be a good idea to share with you my PowerPoint presentation today in this lesson. Before we get into the actual lesson, I'm going to show you how to sketch this function on the board. But there are so many information we need to know about the polynomial characteristic so that we can sketch them easily. So before I get into the lesson of actual sketching it, I would like to share with you all the data, all the information about this, my MS PowerPoint presentation, also to encourage you to register to my math courses online, because I'm guaranteed with you that you will learn a valuable lesson. It's interesting, and you will have my Zoom support as well if you need help and you have any question. So let me share the screen with you now, and I will explain each slide, and I will go through with you one by one, and I will explain the meaning of it. So thank you for sharing, and please forgive me if I make any technical mistake. I'm not a very advanced technology person, but I know that mathematics need technology and technology need mathematics. And we need each other to work as a teamwork. And I try my best. So please bear with me in a minute and let me share the screen with you now. So I am going to organize to present to you in the way that you can see it. So this lesson is how to sketch polynomial function. So that is the title of the lesson today. We will learn. Next, I am talking about multiplicity and their effectiveness on the graph of polynomial function. So number one, if x minus a has a multiplicity of 1, the graph of f function, of course, crosses the x-axis directly at x equal a as shown below. So if you look at on the left graph here, this is the x equal a. Now, why do we say a? Because we just want to represent any number. So the a here could be -5 or -1 or -2, whatever it is. So that's why we use the general letter a, represent for any number. on the negative side of the x-axis. So you can see that this is the linear graph, but the linear graph is also belong to the polynomial function. And it just happened that the x have a power 1 degree. So we call it linear. If x have a power 2, we call it quadratic. So this is the linear function. Cut the x-axis as 1 point, and therefore x minus a is a factor of it, but x equal a, this point here, is where the function across it directly. If you look at the right side of the graph, there is a curve here, so this is no longer a linear. However, it's also across the x-axis as 1 point here, the orange point here. And again, we name this point as A. So A here can be 1 or 2 or 3, whatever number we assign, we scale on the x-axis. So if the function across directly at 1 point like this, we call a multiplicity 1. And it happens for odd number. For example, if you have x to the power, actually it x to the power 1, you will have multiplicity 1 like this. So let's go to the next slide and see what happened. So for the next slide, I'm talking about multiplicity and their effectiveness on the graph of polynomial functions. In this slide, you will see if x minus a has a multiplicity of 2 or even numbers, then the graph of f of x touch the x-axis, but does not cross as shown below. So you see, like here is a curve, and this curve, this function f of x, just touch the x-axis at 1 point. And again, we name this point is A. So it could be, this point could be number -3 or -2, depending on how we scale the x-axis. But you can see that you can visualize it, right? This graph is not crossing the x-axis like the first graph you see, but it's touching it. It just touch it. And it looked like the parabola. It looked like the shape of the parabola. So that's why we call a multiplicity 2. So in that case, this factor x minus a will have a square power on the top like this. And then you know the shape of the function will touch the number a here at 1 point like this and not crossing it. It's like a shape of parabola. Again, if you look at the right function here, this is another shape of parabola. It touches the x-axis here. And in this case, we have a minus sign, and that's why this open downward. And here we don't have a degree of 2, but we have a degree of 4. So if x happen to have a degree of 4, if the polynomial function happen to have a degree of 4 like this, or degree of 2 like this, they might to have, they have the shape touching the x-axis. So at this point, the two roots join in one root, and it becomes root 1, root 2 together. Now, in the case of the x to the power 4, it means 4 roots join at this 1 point. And it could happen like that as well. Okay, so the next one, you will see multiplicity 1 and 2 are even numbers as shown on the sketches below. So let's make an observation with me right now. You see this this polynomial function, it start from here, go across the x-axis at, let's say if I count, oh, I don't know, I make a mistake because I pressing the button. So I don't know how to see if I can go back. See, that's my problem. No. Let me go back. What's wrong with you? Okay, so here, go back. Let me go back. No. This button is not appear correctly. Sorry for this happen. Okay, now I hope that I will not be in trouble anymore. Okay, so you see that right here at this point, we have a multiplicity 1 because it across the function across the axis as 1, 2, 3, 4 at -4 right here and -1 right here. This point is multiplicity 1 and at 2 right here, 1 and 2. So this function also have a multiplicity at a point of x equal 2 right here. Let's make an observation for the next graph. For the next graph, you see that this graph have touched the axis at one point, -3 right here. And therefore, we call this is a multiplicity 2. It looked like a degree 2 when the parabola we draw it. So this is at -3, the a here equal -3, and the x of -3 here represent for letter A, and this sketching touch the x-axis as -3. And this, at this point, we call a multiplicity 2. What about the next root of the function? The next root of function right here, where the function across the x-axis at number 5, at unit 5, and at 5 here, this show us this is a multiplicity 1. So this graph show us both multiplicity 1 for 1, 2, 3, 4, -4, -1, 2, and to the next graph, multiplicity 2 at -3, and multiplicity 1 at x equal 5. So I hope that now you understand what's the name of the multiplicity mean. So now I will show you a next graph of the polynomial function. And in here, I state if x minus a has a multiplicity of 3 or an odd number greater than 1, the graph of f crosses the x-axis with this general shape. Looks like it will bounce, but at the 0, it changes direction and crosses. So what do we talking about? Where are we talking about this scenario? I can tell you the first scenario right here is a function from left to right. It have a multiplicity 1 at x equal -3 and x equal -2. Then at 1 here, at x equal 1 here, you see this point, the function have a shape like it look like it bounce, but then it's not bounce, it change direction, it go up. So from here, it seems like the slope is of this graph is going down, but then at 1, it's spread out a little bit, it expand a little bit, it spread out a little bit, and then it change direction and it go up. So this point, at this point of 1 here, of x equal 1 here, we say this is the multiplicity tree. When the function have an odd degree or have a power 3 degree, or maybe power 5 or power 7, bigger than power 1. So if power 1, we have multiplicity 1 at x minus 2 and x minus 3. But at 1 here, we have a multiplicity of 3. So these are on the mathematical terminology we have to learn in this course. So it's easy for you to see it and visualize it at the same time. So that's why I'm making this PowerPoint presentation before I'm showing you how we get the polynomial function on my board. So let me go to the next slide. So in the next slide, I show you the two shapes of the polynomial function. On the left, I have the shape of the polynomial function. And I'm talking about how do we identify the multiplicity of the first graph here. So I state here from left to right, we have multiplicity of 2, which is at x equal minus 1. And we have multiplicity of 3 at x equal 2. And multiplicity of 1. So these are the number of multiplicity I put in the bracket at x equal 4. So that is the left. Now let's talk about the right one. For the right one, you can see that I show you this polynomial function. From left to right, we have a multiplicity of 1 right here at x equal minus 1 minus 2 minus 3, right? You see like minus 3. And number 2, multiplicity of 2 right here at x equal minus 1. And then the last one, we have a multiplicity of x equal 3 right here. Again, you will see the function like expand a little bit, touching this like a parabola, but then across the x-axis and change the direction. So look like this is curved up, but actually it turned out it curved down. So it's like a turning point, right? So now you understand about what the word multiplicity mean in the graph, on the graph. Now, the second point I would like to mention in this slide is you will pay attention to the direction of the polynomial function. If the polynomial function have an even degree, then their direction is the same for the ending behavior. So you can see that the function start from quadrant 2, quadrant 3 here. If you have a 4 quadrant for the coordinate, you name this is quadrant 1, quadrant 2, quadrant 3. So this function starts from quadrant 3 and then go up and down and end it up with the quadrant 4, but have the same direction. So quadrant 3 and quadrant 4, and they have the same direction. They both going toward downward, right? They're not upward, not one down, one up, but they both downward. So that's for the even power, usually the graph have a same direction like this. Now let's count how many degrees for this function. Right here, we have a degree 2. And then here we have degree 3. So 2 add 3 is 5. And then one more degree here, which is 6. So this is the x to the power 6 function. It has the leading coefficient. We don't know how many, but we know the highest degree for this polynomial function is power 6, because we have power 2 right here, and power 3 here, and power 1 here. So 2 add 3 is 5, 5 add 1 is 6. And because it's even power, so the direction of the graph, they both going the same direction downward like this. Now let's go to the next graph. The next graph also going downward for both directions. So possibility of this graph is even degree as well. Let's count how many degrees this graph have. 1, because it's across here, 1, 2, so 1 add 2 here is 3, 3 add 3 here is 6. So this polynomial function have a degree of 6, which is even, and that's why the graph going down, they both going down towards downward like this from the start as well at the ending. So this graph have a x to power 6 degree. So next one, here I show you the tree graph of the polynomial function. The first sketch is right here. We can see that this sketching are different from the other one. Now, if you notice, right, the function start from the quadrant 3, and then it go up. It doesn't touch the x-axis. It across the y-axis, and it go down, crossing the x-axis at about 1.7 something, right? And then it going up. So one direction downward and the ending direction go upward like that. They're not the same direction. And this sketch, therefore, we know it have to be an odd degree. It's not even degree. So let's count how many degrees this function have. 1 for this, and maybe 2 for this shape, but it doesn't look like, it doesn't go through the axis, right? So it's hard to say. Let me see how many roots it has. 1 root here, 2 root here, and 3 root here. So this shape could be a cubic function, but it could be more than that. But however, this is the odd degree. And it's from left to the right, multiplicity. So I said, let's identify it, right? Or let me go back. Something wrong. I sketch. Let me go back. I try to, I cannot because I have to enter. So from left to right, I would like you to be able to enter the multiplicity degree in here, right? So from left to right, you will, if I click on this, it's not going to go. It's going to go. So let me get back to you, and sorry for the technical problem. Okay, so I will leave this blank. The purpose I will let you key in this is multiplicity 1, and then 1 again, and then 1 again. So in here, you will key in 1, comma, 1, and comma 1. Now from left to right, the multiplicity here, you will key in 2, because this is degree 2, right? At x equal minus 1, we have multiplicity of 2. And then at 2 here, the x across the 2 here, but in a very large behavior, right? Expand, the function expand very large, like almost flat. The slope almost flat at 2 and then go up. So this is the multiplicity tree. So you will say 2 and 3, you will key in down here, 2, 3. And the next will be 1. So you key 2, 3, 1 for this middle image here. Now for the next image, you will enter the multiplicity of 1 at x minus 3, 1 at x minus 2, and 3 at x equal 1, and that's it. So that's the purpose of this slide. We'll like to go to the next slide. So for this slide is a summary of steps in drafting a polynomial function. So step 1, you will find the x-intercept by solving the equation f of x equals 0 and by factoring it. These are the lessons about long division and synthetic division. We went through that in my previous video already. So if you want to know about this topic, please go back on my YouTube channel and seek for the previous video about polynomial function. Or you can follow me on my math teaching dossier and register to my math course online. So now the step 2, you look at find the y-intercept by solving the f of 0. What does that mean? It means we will set the x equals 0 to solve for the y-intercept, because we know that when x is 0, y is something. So that's how you find the y-intercept, by setting on the x equals 0 and solve for y. Step 3, determine the general shape at x-intercept. So I believe that this step 3 to show you to find the multiplicity, right? At each x-intercept, you will define what the shape of polynomial look like. Does it look like multiplicity 1 or 2 or 3? We just went through that. Step 4, looking at the leading coefficient of the polynomial to determine the end behavior of the draft direction. Now this need a little bit explain the side word for you to see. As I mentioned, the draft of polynomial have 4 quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we have to know where we start our pen. We start from the quadrant 3 and go up, or we start from quadrant 2 and go down. So that's the idea of this step 4. Step 5, determine the numbers of turning points. And step 6, plot a reasonable number of points and draw a smooth continuous curve. So that is a 6th step when you sketch the polynomial function. So let me go to the next slide. Here I'm talking about here. Things you must know, the coordinate grid have 4 quadrants as shown on the left image. So quadrant 1, quadrant 2, and quadrant 3, and quadrant 4. So when you sketch, usually you always sketch from left to right. You never sketch from right to left, right? So you have to know your pen. Where your pen? Do you put the pen on the quadrant 2 and then you go down across the x-axis and go up again? Or you start from quadrant 3. So this will be determined by the leading coefficient and the sign in front of the number leading coefficient. That will be decided that when I show you how to sketch this function on the board, you will understand this more thoroughly about where do we put the pen. Do we put up from the quadrant 2 and go down, or we put from the quadrant 3 and then go up, right? That will be decided by the leading coefficient number and the sign in front of it. So let's go to the next slide. Remember, when sketching a polynomial function, you must know which quadrant the function starts from and which quadrant the function ends. So if you have an odd degree, you will start 1 up and end it with 1 down. If you have even degree, if you start from the direction up, then the ending point will go up in both directions as well, like that. That's what I mean. So let's go to the next slide. So here we'll give you a more understanding about the multiplicity and the shape of the polynomial function. So let's take a look at it. You have a function y here equal bracket x minus 5 bracket x plus 2 to the power 2 bracket x minus 7 to power 5. So obviously the bracket x minus 5 here represent multiplicity of 1 because it have 1 power here. X of 2 has a multiplicity of 2 because it have a power 2 here. X minus 7, this bracket have a power of 5. So we call this is a multiplicity 5. So the n direction, I'm talking about here the n direction, even degree with leading coefficient of power 8. And so this function have a highest degree of x to power 8. And y, we can count. 1 at 2 is 3, 3 at 5 here is 8. And that's why when you multiply on the x together here, the highest degree power of x is x to power 8. And direction are the same. So they both have the same direction, whether they both going up or they both towards downward like this or going upward like this. Now in this case, we can see that both of them will end up going upward because no, let me see. They're both going downward actually. No, because x of power a. So if x is very big, large, positive, negative infinity on the left, right? But because you power 8, you powered even power. So yet it starts from the first quadrant, from the second quadrant, and then it ends in the fourth quadrant in the same direction. Okay, so let's look at the next y function, fx function. You have minus x plus 3 times x minus 3 to power 3 times x minus 6. So x plus 3 represent multiplicity 1. X minus 3 multiplicity 3 because this is power 3. X minus 6 also multiplicity 1. So you know the x will across at negative 3 and across at 3 with the expanding shape, right? And then across at 1 point directly at x equals 6 right here. So the highest degree for this polynomial function is 1 at 3 is 4, 4 at 1 is 5. So higher degree is 5. It's the odd degree, so the n direction are different. 1 up, 1 down, or 1 down, 1 up. So I state here start from quadrant 2. So it starts from quadrant 2 and end of quadrant 4. So it starts from quadrant 2. This is higher degree is 5. So x to the power 5 is negative, but because you have a negative in front, so start from the quadrant 2 and end at quadrant 4. Now you might not understand how do we know it start from quadrant 2, but when we sketching this on the board, I will explain more about this. So we hope you enjoyed this PowerPoint presentation, and so that is the ends of my PowerPoint, and here just a little big picture make you smile. Have some fun, everyone, by looking at me. Good luck for your homework. He's such an adorable dog. I have a cat, but I love dog too. So thank you for watching. I'm going to end the PowerPoint here. And if you register to my math course online, of course, you will have accessible to all of this information. I will upload the practice sketching how to sketch the polynomial function for all the students who ever enroll in my course. I will upload the practice package exercise, and it will be beautiful. I will show you. Let me see if I have it here, so I can show you. You can practice it. Sorry, I think that I'm not prepared for this. Let me sit up. It's here. So I would like to talk a little bit about the assignment. If you register to my course, you see this is the assignment, right? So this assignment will allow you to look at the function like this, and you will write the equation, the function, by looking at the shape of it. You'll be able to write the equation for each sketching here. And on the next page, I have a bunch of practice exercise for you to do, right? And there's the answer key here to guide you to find if you answer correctly. So this is the lesson 5 assignment about the polynomial function. Also, at the end of the unit, you will have the home package like this to practice your knowledge, your understanding about the video you watch from my video lecture. Also, you will answer each question here. So you see that you have a home package to try on and to practice on. So it's very useful for you if you register to my course. You will have access to all of this information like this. Now you can watch me on YouTube, but let me tell you one thing. I think this light is changing, keep changing. So sorry about this. I think it's the sun, the shining of the sun is. So if you just watch me on YouTube, you will understand, but you will not be able to have all of this practice like this. If you want to have all of this practice, and with the guidance and with the support from me for the course, you can, if you got stuck and you don't understand how to do it, you can book in advance with me the Zoom lesson, and we go on Zoom and I will show you everything. So it is a privilege to learn math in a connection way, one lesson after another, and follow the home process and practice, because it's a practice make perfect. So I hope that you enjoy our PowerPoint presentation today online. I share with you, and see you in the next video. Thank you for watching, and bye for now.